Hello and welcome to this repair tutorial, and today we're going to look at a TIAC and the model number is A-R630. This is the Mark II version of the UR amplifier. In terms of general specifications, continuous power output is 2 times 60 watts into 8 ohm speakers, but this will increase to 2 times 90 watts if you connect 4 ohm speakers. Frequency response is 10 Hz to 65 kHz. And total harmonic distortion at 1 kHz is 0.05%. And then for input sensitivity, you can connect directly a turntable with a moving magnet type cartridge. This is at 2.8 millivolts, impedance of 47 kiloohms. And then for all of your other line inputs, it's 180 millivolts, but again into 47 kiloohms. On the front, you also have a loudness switch. You can also mute the amplifier. And as you would expect, headphone jack socket 6.5mm for personal and private listening. You also have a microphone input as well with an adjustable sensitivity level, and then individual bass, treble, balance controls. You can also defeat the tone control circuits by operating the direct mode, and then overall dimensions: width is 435 by height of 142 and depth of 355mm. And the amplifier weighs 8.1 kilograms. And there's also a R650 series, which is slightly larger in terms of output power than the 630, and there's also, as you appreciate, a Mark I version. But overall build quality is pretty good, and these amplifiers are quite popular, and it's one of the more common amplifiers that come into the workshop. So if we sort of just take a look at the rear of the amp, you can see quite a busy back panel here. What's nice is that you have dual speaker outputs. So this is where you can have 2 sets of speakers connected. Just above the speaker terminals, you can also see that there is a power socket. So again, if you need to power other devices within your system, you can take the power from there. On the left hand side, you can see that this is the phono input, the moving magnet type cartridge, also the common ground connection, and then all of your other line inputs and preamp outputs. In the middle, you can see this grill. So there is a fan which is used to cool the amplifier. Maybe if it's being used extensively, or maybe it's at fairly high volume, then the fan will operate, triggered by temperature. Now, when we look from the top of the amplifier, and there's a number of things that we just need to sort of highlight. If you look towards the rear of the amplifier, you can see that there is a small circuit board, and this is where you have this secondary power output to power auxiliary units within your system. On there is the startup circuit. So what you can see is that there is a small transformer, and we'll see this later, and that is a startup transformer. And then what will happen is that it's providing power then to the microprocessor. And then if you operate the amplifier from the front or via the remote control, maybe you're switching it out of standby, or maybe you turn it on for the first time, the startup circuit's going to be providing the power. Now, providing that there is no fault condition, then the amplifier will start up probably about 5-6 seconds later, and you should hear the speaker protection relay switch over depending on which speaker sets that you've got selected. If that was not the case, then you may see that the LED on the front of the amplifier just remains red and then flashing, and that was the case for this amplifier. The other thing that you can see as well is if we look towards the left hand side but closest to us, that is where you see the power transformer, and that's the EI type. You can see the cooling fan in the center, and you can see the very substantial heatsink where the power output audio transistors are mounted. And then on the right hand side, this is your various circuitry for your inputs, also for your phono stage, and then you also have a low voltage power supply as well. Just on the left, looking back where you have the startup circuit board, you can just about make out the large electrolytic capacitors as well, but again we'll sort of look at that in a little bit more detail in a moment. And then here, if we look from the rear of the amplifier, this is your volume control circuit. And you can see that there is a motorized potentiometer for the volume control. And it's quite straightforward to remove this circuit board. It just plugs into the main, what I would term as the microprocessor stroke tone board. And that board also contains all of your LED indication as well. And then here, if we take a close-up view, this is the startup circuit. And you can see the various connectors coming in, both for the power input, and then it is then switched to the power transformer via the relay, which is just within shot. And then you also have a protection fuse for this circuit. For this amplifier, because it's more recent, you don't have this issue with the brown glue, but what you can see is that there is a non-conductive, it's like a rubberized material which has been deposited onto the circuit board just to try and hold some of these larger components and provide more structural strength. If we look in more detail, you can see that this same material has been spread across the pins of the transformer, but there's no reason then to remove them. Just to the right hand side, I want to highlight this, there is a grounding connection. You can see this spring copper mechanism. Now, if you're going to be repairing the amplifier and then you sort of start it up, what you may well find is even if you have carried out the repair correctly, it may not come out of the standby mode or seems to be in the protection mode. You just need to make sure this circuit board is in place and it's actually grounded, because you do have these common ground connections between the different screws when you look from the rear back panel. Just taking a zoom in view. So these are the larger power supply electrolytic capacitors. So there's two of them and they are 6,800 microfarad rated at 63 volts. And again, we see this white material just around those capacitors because this is what the manufacturers do. My own personal opinion, completely pointless. These components don't just drop out of the circuit board. The pins are substantial. They're going to be soldered in place, but that's what they choose to do. And then here, if we just zoom in, this is taking a side view. And again, a number of things which we want to sort of point out. If you look towards the nearest part of the photograph here, you can see that there are small individual coils. And then this is the circuit for the phono moving magnet type input. And then you can also see as well that there is an input selection IC. This is the custom one. So in terms of input switching, it is all digital. So you don't have any mechanical switches. You just have dedicated IC, which is then switched from the microprocessor. And then towards the back or to the rear of this photograph, you can just make out these are the audio output transistors which are mounted onto the heatsink. Now, as I said earlier, what was the issue with this amplifier? And it was in protection mode. So the power LED was just strobing. And then normally the symptom is if you turn the amplifier off, because you've got the main power button, then you have the standby button. If you put the main power button on and then hit standby, within about 5-6 seconds, you should hear the amplifier spring into life. What you'll tend to hear is if it's in protection mode, you hear the startup relay just click and then it clicks back off again. And you can't go any further, but again, it's just flashing, indicating that there's an issue. Now, in terms of strip down, it is quite straightforward and it's quite easy to work on. So what I've done here is I've removed the main circuit board, which we saw earlier. And then here, looking from the rear with the back panel removed, you can see you have the power supply just on the right-hand side, EI transformer. I've just moved out of the way the startup circuit board, and then as we said, there is the tone control stroke micro board with all your indication on there, and again the volume control. You can just also make out as well the circuit board just beneath the volume control board is where you have the microphone input and additional number of switches. Now, once you put the chassis to one side, what I've done here is I've just zoomed in. I've sort of highlighted some issues that we're seeing. The first one is that you have discoloration on these resistors here. Typically what will happen when the amplifier is in protection mode, it's either the left channel or the right channel that fails. So what you have to do, of course, is to make a number of measurements. And what you'll normally find is that the audio output transistors or the Sanken audio output transistors, one or both of them will be short circuit. So here what has happened is the transistors have failed and then it has drawn excess current, resulting in these resistors overheating. Now, some resistors, when they fail, you can physically look at them and say, yeah, it's been burnt out and I can see the issue. But on others, you cannot, and you'll only pick that up if you measure with your multimeter. And then here what I've done is I've just turned the circuit board over and I'm highlighting a series of dry joints. Now, I've seen this fault on these amplifiers and it's always the same issue where one or the other of the channels fail. And I don't think it is down to maybe operating the amplifier excessively. I think it comes down to these dry solder joints here. They form on multiple components, which then results in the failure of the output stage. And you can see that some of the components have already been desoldered, and we'll come back later with an extract of the circuit. I'll highlight which resistors and other components failed, but that's why I'm just circling, just to highlight this is just one of many, many dry solder joints. So although we carry out the repair, it's very important, as with all of these tutorials, just take the time to inspect all of the different solder joints and reflow them. What you don't want to do is just replace the components and then power up the amplifier, because those components may well fail again. And then here what I'm showing you is an extract from the service manual, and this is for the right channel, and it was indeed the right channel which had failed. And just to the bottom, you can see here that we have all of the different components. So you have the components that will replace is R629, R628, and these are the emitter resistors, which are 0.22 ohms rated at 5 watts. And then you also have R625, which is 680 ohms, and R626, which is 470 ohms. So those are the resistors on the previous but one photograph where I'd highlighted and they'd started to overheat. And I've circled all the individual resistors which have failed here from the extract from the service manual. And then the other resistors is R622, R623, which are 100 ohms, and they're 1/4 watt. And then what also caused all of the failures of the resistors is the shorting from a collector to emitter of the Sanken audio output transistors. So here for this unit, because it's a 630, Q614 is a 2SC2837 and Q616 is a 2SA1186. Now, once you'd replaced all of those components, it's very, very important just to take a period of time, right? I've said this many, many times. Don't rush the repair. Replace the components, but then also use your multimeter just to verify that there's no other resistors which have burnt out. And again, they may well have failed, but there's no visual indication. They just go very high in value. And then the same also for the respective transistors. And you can make a quick comparison with the working channel as well. And then once all that has been done, you can see here that we need to adjust the bias setting on both of the channels. And that's very easy. All that you're simply doing is you are measuring across one of the emitter resistors, but there is actually a test connector on the circuit board. Now, what is not very easy is gaining access to the left channel one, because you're going to have the back panel in place and the startup board and that ground connection, and then the amplifier will start up correctly. So what you need to do is to make up a lead so you can plug it in, and then there's a small cutout where it comes up from the bottom of the circuit board, passes through the startup board, and then you can then connect it to your multimeter. Then you can make the adjustment. So in this case, CN53 is the connector, and then you have the preset, and we're just adjusting it to get a bias reading of 5 millivolts across the emitter resistor. And then here what you can see, this is a before screenshot, and the channel is running high at 7.32 millivolts. Not excessive, but not 5 millivolts. And then here, if we sort of zoom out, you can see this flying lead which I've made up, and it plugs directly into the test connector, and then it goes all the way back, and you can just see in the distance there the multimeter, and on this channel it's reading 7.21 millivolts. And then once the amplifier has warmed through, you can then make the adjustment, and then here we've set it back to 5.01 millivolts, and then that was the same for the other channel. You've got a small amount of tolerance on that. It doesn't have to be bang on 5.00. But again, once you've done the adjustment, just leave the amplifier running just so it just stabilizes, make sure everything is good. And then you can recheck and maybe make a slight adjustment after that. I also check as well on the rear terminals the DC offset, but on this amplifier it was very, very low. But there's no adjustment to make. You don't have another preset to eliminate any high DC. But if there was, then the protection circuit would trip in and operate anyway. And then here what I've done, as with many tutorials, I've just took a photograph of all of the different components which have failed. There you can see the Sanken power output transistors, the two 1 watt resistors which have burnt out, and then also the smaller 100 ohm resistors and the emitter resistors. With the emitter resistors, again, you'll see no visual indication of failure at all. It's only when you put your meter on there that you'll start to read that they're in kilo ohms, or in this case mega ohms, and completely open circuit. So once all the work was done, the only thing that remains is just to place the amplifier onto test, and this ran for 4 hours and faultless. But I do reiterate the point that you do need to look at all of the circuit boards and reflow or resolder any of these dry joints. It just prevents any future issues. And overall, this is a good performing amplifier, and the audio quality is very, very good. So that sort of brings us to the end of this repair tutorial. So I appreciate you stopping by. And again, if you need any help, support or guidance, by all means email audioamplifierservicing@aol.com. I'll be more than happy to come back to you and provide any support that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.